Distance and displacement are fundamental concepts in physics that help us understand how objects move. At first glance, they might seem similar, but they have distinct characteristics that set them apart. Distance is a scalar quantity, while displacement is a vector quantity. The distinction between these two is crucial for understanding motion. Let's start with distance. When we talk about distance, we refer to the total length of the path traveled by an object, regardless of its starting or ending point. It's a straightforward measurement that tells us how much ground an object has covered. For example, if you walk from your house to the store and take a winding route, the distance you've traveled is the sum of every step you took along that path. It doesn't matter where you started or where you ended up. Distance is purely about the journey itself. It's measured in units like meters, kilometers, miles, and so forth. The key thing to remember is that distance does not have a direction associated with it. It's simply a number that tells you how far you've gone. Now let's shift our focus to displacement. Displacement takes into account not only how far you've traveled, but also the direction of your travel. It's a vector quantity, which means it has both magnitude and direction. To illustrate this, let's use the same example of walking from your house to the store. If you walked in a circle and ended up back at your house, your distance traveled might be quite large, but your displacement would be 0 because you haven't changed your position. Displacement is calculated as the straight line distance from your starting point to your ending point, along with the direction of that line. If you walk directly to the store, your displacement would be the straight line distance from your house to the store, along with the direction indicating which way you went. This distinction is vital in physics because it helps us analyze motion more accurately. Now let's talk about speed and velocity. Speed is a scalar quantity, just like distance. It tells us how fast an object is moving, but it doesn't provide any information about the direction of that motion. For instance, if you're driving a car at 60 miles per hour, that's your speed. It tells you how quickly you're covering distance, but it doesn't indicate whether you're going north, south, east or west. Speed is calculated by dividing the total distance traveled by the time it took to travel that distance. So, if you drove 120 miles in 2 hours, your average speed would be 60 miles per hour. On the other hand, velocity is a vector quantity. Just as displacement includes direction, velocity does too. If you're driving that same car at 60 miles per hour to the north, your velocity is 60 miles per hour north. This directional component is what makes velocity different from speed. When we analyze motion, knowing the velocity of an object allows us to understand not just how fast it's going, but also where it's headed. Understanding the difference between speed and velocity is particularly important in everyday life. For instance, when you're driving, knowing your speed can help you adhere to speed limits, but knowing your velocity can help you navigate to your destination. If you're heading to a friend's house, you might need to know not just how fast you're going, but also in which direction you need to turn at intersections. In addition to understanding these concepts, it's beneficial to have some typical everyday speeds in mind. For example, walking speed for most people is about 3 to 4 miles per hour. This understanding helps us estimate how long it will take to walk to a nearby location. If you know the distance to the coffee shop is 1 mile, you can estimate that it will take you about 15 to 20 minutes to walk there. When it comes to cycling, an average speed might be around 12 to 16 miles per hour. Knowing this can help you plan a bike ride. If you want to cycle to a park that's 10 miles away, you can expect to arrive in about 40 to 50 minutes, depending on your speed and the terrain. Driving speeds vary significantly depending on the type of road. On highways, the speed limit is often between 55 to 75 miles per hour, while in residential areas, it might drop to 25 to 35 miles per hour. Being aware of these typical speeds is essential for safety and for planning travel times. If you're driving to a city 100 miles away on the highway, knowing that you can maintain an average speed of 65 miles per hour helps you estimate your travel time to about 1.5 hours, not accounting for traffic or stops. In contrast, public transportation speeds can vary even more. Trains might travel at speeds of 50 to 80 miles per hour, while buses may average around 30 to 40 miles per hour due to frequent stops. Understanding these speeds can help you make informed decisions about which mode of transportation to use based on how quickly you need to arrive at your destination. In conclusion, grasping the concepts of distance, displacement, speed, and velocity is not just an academic exercise. It's a practical skill that enhances our understanding of motion in the world around us. Distance as a scalar provides a simple measure of how far we've traveled, while displacement gives us a more nuanced view by factoring in direction. Speed offers a straightforward way to gauge how fast we're moving, while velocity enriches that understanding by incorporating direction. By familiarizing ourselves with typical everyday speeds, we can navigate our lives more effectively, whether we're walking, cycling, driving, or using public transport. These concepts form the foundation for understanding motion, and they're essential for making sense of our daily experiences.